Question 1. So at the top we've got use pressure equals force in newtons divided by area in centimetres squared. And we've got a picture of a filing cabinet here. The base of a filing cabinet is a rectangle. So the base is a rectangle. It measures 45 centimetres by 60 centimetres. The whole of the base is in contact with the horizontal ground. This is important when we're dealing with pressure, force and area. Part A. The empty filing cabinet exerts a force of 675 newtons on the ground. So we've got a force of 675 newtons. What is the pressure exerted on the ground by the empty filing cabinet? So we're dealing with empty here, look guys. Give your answer in newtons per centimetre squared. So we're going to use our pressure, force and area formula that they've very kindly given us. So pressure equals force divided by area. Now we've been given our force and we're trying to work out our pressure. So pressure equals our force of 675 newtons divided by our area. Now the area is the area that's making contact with the surface. So the whole base of this filing cabinet is in contact with the horizontal ground, so this part here, and it measures 45 centimetres by 60 centimetres. So we're going to find the area of the base. So the area is equal to 45 times by 60. Calculator paper, remember, so I'm going to do that on my calculator. 45 times by 60, so that's 2,700 centimetres squared. So that area now is going to go where the area would be in the pressure formula. So now to find the pressure, we're just going to simply carry out this calculation. So 675 divided by 2,700, which is 1/4, which is 0.25 newtons per centimetre squared. Part B. When the filing cabinet is full, so we're not talking about an empty filing cabinet now, the pressure it exerts on the ground is 0.75 newtons centimetres squared. So this is a full filing cabinet now, which is why the pressure is different to what we've just calculated. What is the force that the full filing cabinet exerts on the ground? Give your answer in newtons. Okay, so again we're going to use our force, pressure, force, area formula. So pressure is force divided by area. This time we know the pressure is 0.75, so let's substitute that in. All right, we're looking for the force and we know the area. It's the same area that we were working with before because it's the same filing cabinet. So now to find the force, we need to rearrange this formula. So force is going to be pressure multiplied by area. So 0.75 multiplied by 2,700. Which is 2,025 newtons. Question 2. The diagram shows information about the percentage of households in Eduvale that owned a desktop computer for the even-numbered years from 2006 to 2018. So we've got our even-numbered years, we've got the percentage of households that owned a desktop computer. Okay, so that's like a PC or something that you would have on a desk, so not a laptop or a tablet or anything like that. Part A, complete this statement. The percentage of households that owned a desktop computer decreased the most between the even-numbered years, something and something. So we're looking for the biggest decrease, okay? That's the important thing here. It's a decrease, not an increase, it's a decrease. So let's look at the points that decrease. Well, from 2006, the percentage of households on a desktop is just steadily rising. It's only when we get to 2014 that it starts to drop. So we're going to investigate this area of the graph because this is the decrease. So from 2014 to 2016, we go from roughly 88% to 75%. So let's just make a note of that. 88% to 75%. So that's a 13% drop. let's just double check this one. This one's going from 75% to 72%. That's definitely a smaller drop in the percentage of households. So we're going to say it's between 2014 and 2016. Okay, 2A part 2. Jane says the graph shows that 70% of people owned a desktop computer in 2009 because it passes through that point. Is Jane correct? Yes or no? We have to explain how we decide, so I'm not just going to tick one of these just yet. I'm going to take a look back at that graph that we were working with. So Jane says 70% of people owned a desktop computer in 2009 because it passes through that point. So we're looking at 2009, which would be here in the middle. And if we go up, she's right. 2009, the year, does pass through that point, 70%. However, we have no data for 2009. We've only plotted the data for the even years. So, and the lines that join up these points don't really have a value. Okay, they're just showing us the trend of the data. So that's what I'm going to say. I'm going to say that Jane is not correct because there is no data for 2009. The lines that join the points have no values. Okay, so something around the fact that there's no data for that particular year, so we can't say either way. But also those lines are just giving us the trend of the data. It's not like we've plotted every month or every day of 2008 to 2009, etc. If we'd have done that, we'd have continuous data and we'd probably be able to read it off a bit more accurately. Okay, part B. The table shows information about the percentage of households in Eduqas that had an internet connection for the even numbered years from 2006 to 2018. So this is working with internet connection now. On the diagram on page 4, plot the information for internet connection. So we're going to have to bring our graph back and we're going to plot this information. So in 2006, there was 45% of households that had an internet connection. So we're going to go across to 2006 and then up to 45. So 2006 is here, up to 45 would take us to here. 2008 up to 53. So 2008, 50, 1, 2. My eyes aren't working very well today, guys. 3. 2010 to 66. So 2010, 65, 66. 2012 to 79. So 2012, so 79 is there. 2014 to 84. 1, 2, 3, 4. 2016 to 88. 5, 6, 7, 8. And 2018 to 89. So 2018 up to 89. And then we're going to draw lines between those points, just like we've got for the desktop computer ownership. Now, I'm doing this in pen because I want you to be able to see it nice and clearly on the video. I would recommend you do this in pencil. So then if you do make a mistake, it's easy to rub out and there's not lots of random lines and points to confuse the examiner when they're trying to see if you've plotted the correct ones. Okay, so that is part 1 of B. So we've plotted the percentage of households that have an internet connection. Okay, part 2. In which even numbered year was the difference in the percentage of households in Eduqas owning a desktop computer and the percentage of households having an internet connection the greatest? Okay, so we're looking here, back on our graph, we're looking for the greatest difference between the 2 points that are plotted for each year, remembering that pink is our internet connection and the black is our desktop ownership. So 45 to 55, that's 10. 53 to 62, 9. So these are pretty small jumps. I think it's going to be potentially one of these two because they look bigger. So this one, or this one. So let's just check. So this is 66 and 78. So this is 12. So this is 75 and 88. So that is 13. And this is 72 and 89. So I think this is definitely our biggest, which is 17. So the year that they had the biggest difference is 2018. Part 3. Edgevale is a large town in a county. Comment on how in this county the percentage of households owning a desktop computer and the percentage of households having an internet connection are likely to have changed in this period. So there's nothing really maths wise you can do for this, guys. It's just commenting on what you know about desktop ownership and internet. So we're thinking about our common sense here and the years that we're looking at. So we're working from 2006 to 2018. Okay, so the number of households, the percentage of households that have an internet connection is just going to increase over that time, isn't it? Okay, because more and more people have had the internet over the years and more people are going to continue to get the internet. So I'm going to start by saying the percentage of households with an internet connection would increase. Okay, so we've talked about the internet connection. Now I'm going to talk about the desktop computer ownership. So remember I said a desktop computer is a PC or a Mac. Okay, you know, one that sits on my desk, quite cumbersome, quite big. And over the years from 2006 to 2018, lots of new devices have come out. Laptops, tablets, those kind of things. So actually, it's likely that the percentage of households that own a desktop computer would decrease. So the internet connection would increase, but owning a desktop computer, not a laptop or a tablet or whatever, is potentially going to decrease. So I'm going to add that on. So the percentage of households with an internet connection would increase, but the households with a desktop computer could, we're not going to say definitely, but could decrease. It seems likely, doesn't it, with all the new devices that have come out over the last, 20 years or whatever. Eric is carrying out a survey for a company that makes energy drinks Pop and Whiz. He asked 200 randomly selected adults to complete his survey. Pop costs £1 per bottle. As part of his survey, Eric wants to find out how much money each month adults spend on Pop. In the box below, write a suitable question for his survey. To collect this information, you must include response boxes. Okay, so the important things about questions for surveys, we definitely need to give them a time frame. We can't just say, how many bottles of Pop do you buy? Because that's an open-ended question, isn't it? So we need to give them a time frame. So I'm going to say, how much money do you spend on Pop in a month? Okay. So we've given them a time frame. We've asked them specifically how much money do they spend on Pop in a month, and that month is giving them a time frame rather than it being open-ended. Now we need to give some response boxes. The important thing about the response boxes is that they don't overlap. Okay? Now the good thing about this question is it's £1 per bottle. So we're not going to be spending £1.50 or £1.42 or £2.30 or anything like that. So we don't have to, the overlap is a little bit easier on this one. So first of all, we need an option for nothing. Some people might not buy Pop. Okay, so we need to put that in there. And then we need a couple of different response boxes. So let's go for £1 to £3 spent in a month, £4 to £6 spent in a month, and then let's go more than £6 spent in a month. We don't need to do an exhaustive list of the potential values, but this is for anyone that hasn't spent anything on pop in a month. This is for anyone that spends more than £6 on pop in a month, and then obviously got these two categories here as well. Okay, part B. In another question, he asks the 200 adults how many bottles of whiz they buy each month. And the table shows the results for these 200 adults. So these are their ages, these are the number of bottles that they buy, and here's the frequencies. Find the probability that an adult chosen at random from these 200, so chosen at random from the 200, from the total population, does not buy whiz. Okay, so the total population is 200, so I'm going to pop that straight on the bottom of my fraction. But we're looking for people that do not buy whiz, so we're looking for this column here, the 0 column. So let's total that up. We don't have any particular age to look at, we're just looking at this cohort in total. So 26 plus 29 plus 32 is 87. So I'm going to put 87 on the top there. And that's my probability that they don't buy whiz. Okay. Part 2. We're looking at the probability that an adult chosen at random from these 200 is 26 to 35 years old and buys 5 or more bottles of whiz each month. So we're looking at the 26 to 35-year-old section, which is the middle row. But we're looking also for 5 or more bottles of whiz a month. So it's going to be the 5 to 10 and the more than 10. Okay, so again, 41 plus 2 is 43. The total population is still out of the 200, but it's 43 out of 200 that are 26 to 35 years old and buy 5 or more bottles each month. 4A. The diagram shows a circle inside a square of side 8.2 centimetres. So that's our diagram here. We've got the circle, we're inside a square, and the square's got sides of 8.2 centimetres. The sides of the square are tangents to the circle. So that tells us that they don't cut through the circle, but they lie flush against the circle. So they just touch it slightly at a point. They want us to find the area of the shaded region, and we've got to show all of our working out. So when we're finding the area of a shaded region, we have to find the area of the whole shape, and then the area of the shape that's not shaded, and then subtract them from each other. So I'm going to start by finding the area of the square. Now, they helpfully tell us that the sides are 8.2 centimetres. All the sides on a square are equal, remember. So we're to find the area of the square, we're going to do 8.2 multiplied by 8.2. So that's 67.24 centimetres squared. Now we're going to find the area of the circle. Okay, and the area of a circle is pi times radius squared. Now, we need to find the radius. Now, the important thing here is they've told us that tangents, the sides of the square are tangents to the circle. So we can also say that those sides of the square are the diameter of the circle. So if the diameter is 8.2, we need the radius for the area. So the radius is half of that, which is 4.1. So the area of the circle is pi times 4.1 squared. So pi times 4.1 squared. So that gives us 52.81017. Notice that I'm not rounding, because if I round, I could potentially get an error in my answer when I'm continuing to use these values, because I haven't finished. Okay, so the area of the shaded region is the area of the square, the whole shape, subtract the area of the circle that's not shaded. So our area of the shaded region is 67.24, subtract the 52.81017251. Now notice I didn't delete that off my calculator because I don't want to enter all those decimals in again. So I'm just going to start by typing 67.24, subtract, and then I'm going to press the answer button here. So that'll put my previous answer in, so I don't have to put all those decimals in. So that's 14.42982749. Okay, and that's centimetres squared because we're working with area. The question doesn't ask us to round at any point. You can if you want to, but I'm not going to. It doesn't ask me to. I'm just going to write down all of those decimals. Okay. Part B. So the diagram shows a parallelogram. The parallelogram is a cross section of a prism. So it's the cross section of a 3D shape. Okay, so we're working with a 3D shape here. So here's a parallelogram. We've got a base of 9.8, a perpendicular height of 7, and then that slanted side there is 8 centimetres. The length of the prism is 16 centimetres, and they want us to find the volume. So to find the volume of any prism, you find the area of the cross section, which in this case is our parallelogram, and then you multiply it by that length that gives it its 3D depth. So we want the area of the parallelogram, and then we're going to multiply it by that length of 16. So, area of parallelogram. So, the area of the parallelogram is base times the perpendicular height. So it's 9.8 times 7. We don't need this slanted side to find the area, so we're ignoring that, guys. 9.8 times the perpendicular height. So 9.8 multiplied by 7, which is 68.6 centimetres squared. So that's the area of the cross section. Now to find the volume of the prism, we need to multiply the area of the cross section by the length. So the volume is equal to 68.6 multiplied by 16. I didn't delete my answer, so I can just press multiply. It'll bring my previous answer, 16, and then that gives us 1097.6, but it's centimetres cubed this time because we're working with volume. Question 5a, solve 7x subtract 5 equals 2x add 3. So 7x subtract 5 equals 2x add 3. The only reason I'm writing that equation out again, guys, is I like space to show my steps and working out. So we have an equation to solve where the unknown variable x appears on both sides. So what I'm going to do is I'm going to eliminate the smallest term, the smallest x term. Okay, so we've got 7x and we've got positive 2x. I know that that's a positive 2 because there's no negative sign in front of it. So if I compare 7x and 2x, 2x is the smallest x term. So that's the one I'm going to eliminate. So to eliminate positive 2x, I need to take away 2x. So when I take away 2x from the left-hand side, 7x take away 2x is 5x. I've still got that minus 5, didn't do anything with that. When I take away 2x from the right-hand side, 2x subtract 2x is 0, so that's what eliminates it, and I'm left with that positive 3. I've now got a two-step equation, so I'm going to eliminate the negative 5. Remember, I'm aiming to solve for x, the unknown variable, so I want it to end up being x equals, so I'm trying to isolate it. So I'm going to eliminate the subtract 5. The opposite of subtracting 5 would be to add 5. So 5x, negative 5 plus 5 is 0, so that's what eliminates it for me. And then I need to do the same on the right hand side so that I'm balancing the equation. 3 add 5 is 8. Now we're working with a one-step equation. 5x is 5 multiplied by x. The opposite of multiplying is dividing. So to get x on its own, to isolate x, I'm going to divide by 5. 5x divided by 5 is x. I need to do the same to the right-hand side. 8 divided by 5, well, I'm going to write it as 8 over 5. Now, when I look back at the question, it doesn't ask me to give my answer as a fraction, a decimal, etc. So I'm just going to leave it like that. It's accurate, and it's just remembering the fact that a fraction is a division. Part B. Rosa is buying bananas and apples. She buys X bananas, which cost 30p each. She buys 2 more apples than the number of bananas she buys, and her apples cost 25p each. She pays a total of £5.45. Use an algebraic method to find the number of bananas Rosa buys. So we're using an algebraic method, so we are going to have to form some algebraic expressions, potentially even an equation, and solve it. So let's start with an expression for the number of bananas. Okay, so the number of bananas that she buys is X. But then they tell us that the total cost is 30p per banana. So we can also write an expression for the total cost of bananas, which is that 30p multiplied by the number of bananas, which is X. Okay, let's form an expression for the number of apples that she buys. So it says she buys 2 more apples than the number of bananas. Okay, so if the number of bananas is X and she buys 2 more apples, we can write that as X add 2. So now we can form an expression for the total cost of apples. So it tells us that apples are 25p each, so the total cost would be 25 multiplied by the number of apples, which is X add 2. Now I'm going to expand that bracket now. So 25 multiplied by X is 25X. 25 multiplied by positive 2 is positive 50. Okay, so the next piece of information they give us is the total that she spent. So that would be the total of the cost of bananas and the cost of apples. So we can now form an equation. So the total cost of bananas plus the total cost of the apples must equal £5.45. Now these are all working in pence, so I'm going to work in pence for my calculations as well, because working with 545 will be a little bit simpler than 5.45. So that's 545 pence there. Now I'm going to collect like terms to get myself to a simple equation that I can then work with and solve. So 30x plus 25x is 55x. So 55x add 50 is 545. So we've got a two-step equation here. So I'm going to eliminate that add 50. Remember, I'm trying to isolate x so I can solve it, because x is my number of bananas. So I'm going to subtract 50 from both sides, because the opposite of adding 50 would be to subtract 50. So when I subtract 50 from the left-hand side, it eliminates 50, because 50 subtract 50 is 0. When I subtract 50 from the right-hand side, 545 subtract 50 is 495. Now we've got a one-step equation. 55x is 55 multiplied by x. The opposite of multiplying by 55 would be to divide by 55. So 55x divided by 55 is x. So I've isolated x. I've got x on its own. I now need to do the same to the other side. So I'm going to do 495 divided by 55, which is 9. So Rosa buys 9 bananas. Okay, part C, factorise x squared, add 5x, add 4. Okay, so when we're factorising this equation, we want to put it into 2 brackets. So we want it to look something like this. The reason why I know I'm factorising into 2 brackets is because I've got a squared term and a constant number term. It doesn't matter about this thing in the middle, but if I have a squared term and a constant number term, it needs to be 2 brackets, because I need x in each bracket, because the x multiplied by x, if I was to expand, would give me x squared. But then I also need 2 numbers inside the bracket that multiply together to give me the 4. So that's where I'm going to start. I'm going to think about 2 numbers that multiply together to give me 4. So I can have 1 and 4 or 2 and 2. Okay. The next step we need to consider is those 2 numbers that multiply to 4 also have to add to give me 5 in the middle there. So 2 plus 2 is 4. That's not going to work. 1 plus 4 is 5. So I'm going to use 1 and 4. And they're both positive, which makes my life nice and easy. Question 6. Heath has £3,000 to invest for 5 years. no extra money will be paid in or withdrawn during these 5 years, he's going to choose one of these accounts. So he can choose account A. So account A has 4% compound interest per year. The interest rates can vary. Okay. Account B has a guaranteed interest at the end of the 5 years of £190 for each £1,000 invested. So part A asks us which account gives Heath the greater percentage increase in his money at the end of the 5 years, and by how much is it greater. Okay, we've got to show how we decide and state any assumptions that we make. So if you look at the bottom here, we're identifying the account that gives him the greatest percentage increase, how much greater it is, and any assumptions that we've made during these calculations. So the first thing I'm going to do is I'm going to calculate how much interest he would earn in account A and account B across those 5 years with that £3,000. So account A. So he's investing £3,000 with a 4% compound interest rate for 5 years. So we're going to use our compound interest formula. So we're going to do £3,000 multiplied by, well, we're doing an increase of 4%. So that would be a multiplier of 1.04. Because if we're increasing by 4%, that's 104%. 104 as a decimal. 104% as a decimal is 1.04. And then we raise that to power of the number of years. So he's investing it for 5 years. So I'm going to pop that into my calculator. So 3,000 multiplied by 1.04 to the power of 5. So that is 3,649.99. It's 958,707, but we're working with money here, guys. So I'm going to round it to 2 decimal places. So that's how much he earns. I'm going to now check what that percentage increase is, because we're looking for the greater percentage increase. So to check the percentage change, we do the difference. So the difference from the original to the new, which is £649.99. Divide it by the original, and then we times it by 100. So 649.99 divided by 3,000 times 100. So that's 21.66%. So I'm going to say that's 21.7% increase. Okay. Now I'm going to do the same for account B. And I can't write. Okay, so account B, they get a guaranteed interest at the end of the 5 years of £190 for each £1,000 invested. So we're going to divide 3,000 by 1,000. So there's 3 lots of £1,000 invested. So at the end of the 5 years, he would have 3 times the £190 that they mention here. So 3 times 190. So you'll have £570 interest. I'm going to find out what that percentage increase would be. So the difference is £570 because that's the interest he's earned on top of the £3,000. The original is £3,000 times it by 100. So I've left 570 in, so I'm going to divide that by 3,000. And then I'm going to times my answer by 100. Notice I didn't times by 100 all in one big row, because calculators do weird things. Okay, 19%. So, account A gives the greater increase. 21.7% is greater than 19%. So I'm going to pop account A there. But we need to know what the percentage difference is. So we're going to do 21.7 subtract that 19%. We're just checking the difference between the percentages. So 21.7 subtract 19, which is 2.7%. So it's a 2.7, it's greater by 2.7%. Now we've got to talk about that assumption that we made. So the assumption is going to be based on this fact here, because for account A, it says that interest rates can vary. Okay, so the assumption that we've made is that the interest rate does not vary across the 5 years because we've used 4% for the whole 5 years. So the assumption is that the interest rate on account A does not vary during the 5 years. Okay, part B. Comment on the effect that your assumption in part A has had on your decision. Okay, so the effect it's had is that actually, if the interest rate does vary, but the interest rate's higher, then the percentage difference would be higher. But if the interest rate lowers, then the percentage difference could actually lower. So what I'm going to comment here is, so if the interest rate does go up for account A in those 5 years, it's still going to be the account that gives the greater percentage increase. Okay, it's just this value that would change. However, if it's lower, it could potentially not be the account that gives the greater percentage increase. So I'm saying my answer could be wrong. So it could be wrong if the interest rate lowered enough in the 5 years. Because if it lowered enough, it could change my answer. B could have the greater percentage increase, couldn't it? Question 7. So the diagram shows a small park with gates at A, B, C and D. So A, B, C and D. The scale is 1 centimetre represents 10 metres. So we're dealing with a scale drawing here because obviously a park is massive in real life and we can't represent that accurately as it is on a diagram without scaling it. So we've got our park there drawn for us. Our scale is repeated here. Really important to remember that. So a new outdoor gym is to be built in the park. This gym should be at least 55 metres from the gate at A and nearer to the gate at B than the gate at C. So at least 55 metres from A and nearer to B than C. Use a ruler and a pair of compasses to show accurately on the diagram the region of the park where the outdoor gym can be built. Indicate clearly the region that is your answer. Okay, so this is a loci and constructions question. And we're working with a diagram here. They've given a scale 1 centimetre represents 10 metres. They've given us this distance from gate A in metres, so we need to convert that to be in centimetres. So 55 metres divided by 10 metres would give 5.5 centimetres because every 10 metre is 1 centimetre. So we're going to construct a region that is 5.5 centimetres from gate A. Now this criteria here only mentions gate A, so it's from a point. So when we're doing the locus of points from a point, it's simply a circle around that point. So we're going to set our compass to 5.5 and then we're going to draw an arc. You can draw a full circle if you want, but we're only interested in the part that actually intersects with that diagram of the park. So this is why I've drawn an arc. So every point on that arc is exactly 5.5 centimetres from A. Okay? Every point inside that arc is less than 5.5 centimetres from A. And every point outside that arc is greater than 5.5 centimetres from A. So that's points to note. The next criteria is they want it to be nearer to the gate at B than C. So nearer to B than C. So we're working with a locus of points between 2 points. So for this, we're going to construct a perpendicular bisector. So you need to put your compass on one of the 2 points that you're perpendicular bisector in and make sure that you go over halfway. So set your compass over halfway. And then you're going to draw an arc from the 1 point, leave your compass exactly as it is, and then draw your arc from the other point. So both arcs need to intersect, which is why we set our compass to be over halfway between them, because that was going to guarantee that our arcs would intersect. So now that they intersect here and here, we're going to draw the locus of points that are equidistant from B and C. So that perpendicular bisector, what it does for us, it not only forms right angles here and bisects B, the line B to C in the middle, it gives us a locus of points that are all exactly the same distance from B than they are C. And I know it doesn't look that way because of how the shape of the diagram, but trust me, everything on that line is the same distance from C that it is from B. So now we've constructed the two criteria that they've mentioned. We're not going to rub any of this out because your construction lines go towards marks, guys. If your examiners can't see those and you mark the wrong region in the end, you're going to lose all of your marks. So do not rub them out. Okay, so we want this gym to be at least 55 metres from gate A. So it's got to be on the arc or past it. On the arc as a minimum, okay, because that's exactly 5.5 centimetres, 55 metres. But it also has to be nearer to the gate at B than the gate at C. So this line is our midpoint of BC. So we're looking on this side of the line and outside of the circle. So I'm going to highlight our area. So we want to keep closer to B. So we're going to be on that side of the line, but we want to be on the arc or beyond it, because it wants to be at least 55 metres from gate A. Well, that's our 55 metre point, so that's the minimum it needs to be. So everything else beyond that point is also acceptable. Now, I'm using a highlighter so you can see nice and clearly. You could simply shade in pencil, just in case you shade the wrong region and you want to rub it out. Even if you shade in pencil, I know you're going to cover those construction lines, but they'll see all of these other ones, so they'll know that you've done it correctly. Question 8. So we've got a diagram here with an aircraft and a right angle triangle formed. The diagram's not drawn to scale, so it's really important to remember that we can't measure anything directly from that diagram. So an aircraft is making its final approach ready to land. The aircraft is flying at 3 degrees to the horizontal, and they've marked that on the diagram for us. So it's flying at 3 degrees to the horizontal, and it's 2.5 kilometres horizontally from the start of the runway. Again, this is the position of the airplane, and it's 2.5 kilometres horizontally from the start of the runway. And it's all shown on the diagram for us. Calculate the vertical height of the aircraft above the horizontal ground. So if we're calculating the vertical height above the horizontal ground, then the bit that we're interested in is this part of our right angle triangle. So that's what we're looking for, okay? So we're dealing with a right angle triangle. We've got some angles. We've got a 90-degree angle here, but we can also calculate this angle here. And the reason why I need to calculate that angle is I've got to use trigonometry. I can't use Pythagoras' theorem on this right angle triangle because I've only got one of the lengths. So it's going to have to be trigonometry. But to work with trigonometry in right angle triangles, I need another angle identified inside that right angle triangle in some way other than the 90-degree angle. So we are 3 degrees to the horizontal. This horizontal is a 90-degree angle. So 90 subtract 3 tells us that that angle there is 87 degrees. So now I have a right angle triangle. I'm going to use trigonometry to find the side that is X. So let's start by labelling our sides. So the opposite side is always opposite the other angle. The hypotenuse is opposite the right angle. And the adjacent is next to the other angle, or the side that we haven't yet labelled. So for this question, we've been given the opposite side as 2.5. We're looking for the adjacent side. So we're working with the opposite and the adjacent. So the trigonometric ratio that we need to use is the tangent ratio, okay? So tan is the opposite divided by the adjacent. So tan of that angle 87 is the opposite, which is 2.5, divided by the adjacent, which is our X value that we're looking for. Okay, so you can at this point either solve that equation using inverses, or you can use the one of the SOHCAHTOA triangles. So we're looking for the adjacent side, so if we cover that up, we're doing the opposite divided by tan, okay? So x equals the opposite, which is 2.5 divided by tan 87. And I'm going to pop that into my calculator. So fraction 2.5 divided by tan 87, close your bracket just to be safe because it'll automatically open one when you put in sin, cos or tan. So it is 0.13101944482. And I know that looks like a strangely small number, but we're working in kilometres here, guys, so it's actually not as small as you think it is. So I'm going to put kilometres on the end. Doesn't tell me to round it in any particular way, so I'm going to leave it like that. Question 9. A factory makes loaves of bread which are wrapped in packaging. Independently, for any loaf wrapped in packaging chosen at random, the probability there is a fault with the bread is 0.02. The probability that there's a fault with the packaging is 0.01. Complete the tree diagram to show this information. Okay, so we've got branches for bread and then packaging. So we're dealing with faults or no faults for bread and then faults or no faults for the packaging. Now we need to remember that these branches need to add to 1 because probabilities sum to 1. It's told us that the fault with the bread is 0.02. That's good. So now we just need to do 1 subtract 0.02 to find out the probability that there is no fault with the bread. So 1 subtract 0.02, which is 0.98. So I'm going to write that probability nice and clearly there. Next it says the probability that there's a fault with the packaging is 0.01. So a fault with the packaging is 0.01. Okay, so I'm going to fill out the fault in both fault sections in the packaging. Now it's these sets of branches here that have to add to 1, not all of these. So 1 subtract 0.01. So we're doing 0.99 and 0.99. So we've completed our tree diagram. Part B, a loaf wrapped in packaging is chosen at random. So we're dealing with packaging here. So a loaf wrapped in packaging is chosen at random. Calculate the probability that neither the bread nor the packaging has a fault. Okay, so we're dealing with the probability that the bread has no fault and the probability that the packaging has no fault. So the probability that the bread has no fault, we're going to start here, is this strand, so 0.98. The probability that the packaging has no fault, so bread has no fault, packaging has no fault, is 0.99. And means to multiply when we're working with probabilities. So we're going to multiply those probabilities because we multiply across the branches with tree diagrams. So 0.98 multiplied by 0.99 is 0.9702. Apologies if you can hear my little dog snoring in the background. Okay, part 2. Calculate the probability that either the bread or the packaging has a fault, but they don't both have a fault. Okay, so we're not doing fault, but we do want bread has a fault, packaging doesn't. Bread doesn't have a fault, but packaging does. So either the bread or the packaging, but not both. Okay, so probability that the bread has a fault, but the packaging does not have a fault. And the probability that bread doesn't have a fault, but the packaging does have a fault this time. So we're looking at those two probabilities. So the probability that bread has a fault is 0.02 multiplied by packaging not having a fault, which is 0.99. .0198. So this time it's the probability that the bread doesn't have a fault, 0.98. multiplied by the probability that the packaging has a fault, which is 0.01. Ooh, standard form, wonderful. So that is 0.0098. Okay, so we want the total of these probabilities. So we want probability of this or this. So with and it's multiply, with or it is add. So we're going to add those together. So we're going to add that to 0.0198, which gives us 0.0296. Question 10. In this question, all lengths are in metres, so that's important. Let's make a note of that. That's helpful. All lengths are in metres. The diagram shows Terry's garden. So we've got Terry's garden here. We've got a lawn and a patio. The diagram's not drawn to scale, so remember we can't accurately measure anything from this diagram. So the patio is a square, so that's this here, and the lawn is a rectangle, which is the lawn here. The area of the lawn is 172.8 metres squared. Use an algebraic method to find the area of Terry's patio. Okay, so we're going to have to use algebra, so we're definitely going to be forming some expressions, equations, and then potentially solving. So let's see what we know. Let's form an equation for the area of Terry's lawn, because we've got all the information we need. We've got the length and the width, so length times width for the area of a rectangle equals this. So area of the lawn. So we would do the length, which is 5xy, multiplied by the width, and that would give us an answer of 172.8. So we have an equation that represents the area of the lawn. Now let's look at the patio. Okay, so let's work with the patio. So the patio is a square. So this is a square, so all four sides are the same. So actually, even though this side's labelled as 4x and this side's labelled as y, we can say that y is equal to 4x. Okay? Y is equal to 4x, and the area of the patio would be 4x squared. Okay? Bear with me. So now we have an equation for the area of the lawn, an expression for the area of the patio. However, we don't know what x and y are. Well, actually we do. We know y is 4x. So I'm going to use that fact that y equals 4x in the equation for the area of the lawn. Because what I need really is to solve and find the value of x or the value of y. Because then I can substitute it into my patio expressions and then find an area, the area of the patio. So I'm going to substitute that 4x in wherever there's a y here. So on the front we've got 5x times 4x, so y is 4x, multiplied by x plus 4x, because y is 4x, which is 172.8. So 5x multiplied by 4x is 20x squared, and x plus 4x is 5x. I'm going to continue simplifying this, guys, because 20x squared multiplied by 5x squared gives me 20 times 5 is 100. X squared multiplied by x gives me 100x cubed equals 172.8. Okay, we're getting somewhere. It's looking nicer. I am now going to solve this equation for x, because once I know x, I can find the area of my patio. So I'm going to divide by 100. So x cubed equals, when I divide by 100 here, 172.8 divided by 100 is 1.728. I'm isolating x, I'm solving for x. The inverse of cubing would be to cube root. So when I cube root this side, I get x. When I cube root this side, so let's do, move my paper, let's do the cube root of 1.728 is 1.2. Okay, so x is 1.2. So now I can find the area of his patio because I know the x value. So the area of the patio is 4 times 1.2 all squared. So let's times that by 4, which is 4.8 squared. So let's square that, which is 23.04 meters squared. So on my answer line, we're going to put 23.04. Question 11. Rearrange this formula to make y the subject. So we want to rearrange this. So instead of being a equals, we get y equals. So let's do this a step at a time, just to be careful and be accurate. So the first thing I'm going to do is I'm going to expand this bracket because I'm aiming for it to be y equals. I'm aiming to isolate y, and while it's inside that bracket with another term, that's going to be tricky. So we're going to expand the bracket. So a equals 7 times x is 7x. 7 times positive y to the power of 5 is 7y to the power of 5. And then we've got plus 2. So now what I'm going to start doing is I'm going to start isolating that y term. So I'm going to aim to get this y term on its own. So the first thing I'm going to do is I'm going to subtract 2 from both sides. So a subtract 2 equals 7x plus 7y to the power of 5. I've subtracted 2, so it's gone. Now I'm still aiming to isolate this 7y to the power of 5 on its own, so I'm going to eliminate the 7x from the right hand side. So to do that, it's a positive 7x. I know it's a positive 7x because there's no negative sign there. I'm going to subtract 7x. So when I subtract 7x here, so it's a subtract 2 subtract 7x equals, and then when I subtract 7x here, it just leaves me with my y term of 7y to the power of 5. Okay, now I'm trying to isolate y. I'm aiming for y equals, so I'm going to divide by 7 because this is 7 multiplied by y to the power of 5, sorry. So when I divide by 7, that will just give me y to the power of 5. But what I need to do here is divide everything by 7. So I'm going to write this, guys, as a fraction all over 7, so I don't miss anything out. Fab. Next, we've got y to the power of 5. We want it to be y equals. The inverse of raising something to the power of 5 is taking the 5th root. So we're going to take the 5th root of both sides to get y. So we're going to take the 5th root. Now I'm going to write this first so that my square root sign goes all the way. Not my square root sign, my root sign goes all the way. So this is the 5th root of that whole thing. Question 12. The box plot summarises the heights in centimetres of a class of students. Use the box plot to complete the table. So we want the range, the median, the lower quartile, the upper quartile and the interquartile range. Okay, so I'm going to start with the median because the median is this line here, okay? I know the median is the middle. We're used to hearing that and it doesn't look like it's in the middle, but that's definitely the median in this box plot, guys. So let's look at this scale from 170 to 180. It's 10 little squares, so each little square must be 1. So that's 170, 1, 2, 3, 4. So the median is at 174. Now I'm going to do the lower quartile. So the lower quartile is this first part of the box here, this first line. So when I read down here, we go 160, 165, 6, 7, 168. I'm then going to do the upper quartile, which is this end of the box, this line. So when I read down here, 1, 2, 3, 4, 5, 6, so that's 186. Okay, the interquartile range is the difference between the upper quartile and the lower quartile. So let's subtract those from each other. So 186 subtract 168. So the interquartile range is 18. The range is the difference between the highest and the lowest. So the highest is 192 and the lowest is 158. So 192 subtract 158, which is 34. There we go. Question 13. Enya's house is put up for sale at the start of April. It does not sell. So at the start of May, the sale price of the house is reduced by 20%. At the start of June, the sale price is reduced by 15% of the price at the start of May. Part A. Enya says, my house has been reduced in price by a total of 35%. Explain why Enya is incorrect. Okay, so this is a repeated percentage change question. So we're going to show why Enya's not correct here. Okay, so we're going to say that it's a repeated percentage change. So a 20% decrease would be 0.8, would be 80% of the original, and then a 15% decrease would be 0.85. Okay, 85%. So to start off with, we're reducing the house to 80%. So at the start of May, the house is at 80%, so it's 0.8 of its original price. But then at the start of June, we're reducing it by 15% of the price at the start of May. So we're reducing the 80% by 15%. So we will have done a repeated percentage change. So when we do that, we'll have been reducing 80% of the original value by 15%. So it's actually 0.68. So that's actually a 32% decrease, not a 35%. So if you just say it's a repeated percentage change, show a little bit of working out, you're going to get those marks, guys. Okay. Next, part B. The house is then sold for £306,000. What was the original sale price of the house at the beginning of April? Okay, so we're doing a reverse percentage here, guys. So I'm going to do one of my proportion tables to organise my information and my thinking. So this is the price and this is the percentage. So the house was sold for £306,000, but it was sold at 68% of its original price, okay? So that's 68%. We want to know what the original price was at the beginning of April before any of these percentage changes. So we're aiming to get to 100%. We want to know what the original 100% was. So the first thing I'm going to do is if I divide by 68, that will tell me what 1% is. But I need to do it to the other side. So 306,000 divided by 68. 4,500. Oh. So that's 1%. So to find the original, I just times that 1% by 100. So if I times this by 100, no, that's 1,000. It's 450,000, and that's my answer. That's the original price. Question 14. The area of country A is 1,078,000 kilometres squared. Correct to 4 significant figures. The area of country B is 249,300 kilometres squared. Correct to 4 significant figures. The two countries merge to form country C. Calculate the upper bound of the area of country C. Okay, so if those two countries merge, we are adding them. Okay, so we're gonna, so A plus B is gonna give us country C. The thing here we're working with is upper and lower bounds, guys. It wants the upper bound, and these are rounded correct to 4 significant figures. So to find the upper bound of the area of country C, because we're adding, we want to add the biggest potential value for the area of country A and the area of country B. So we want the upper bound of A and we want the upper bound of B. All right, we want the maximum value. This is correct to 4 significant figures. So for country A, the 4th significant figure, 1, 2, 3, 4, is the 8, and that's in the thousands column. Half of 1,000 is 500, so the upper bound would be this value plus 500. So that's the upper bound, and we're in kilometres squared. Country B is also rounded to 4 significant figures, so 1, 2, 3, 4. So the 4th significant figure for country B is in the hundreds place value column. Half of 100 is 50, so we would add 50 for the upper bound of the area of country B. Now we're just going to add those two things together. So 107,500 plus 249,350. 107,8,500 plus 249,350. I have to make sure I've entered the right thing into my calculator because I do silly things sometimes. That's, what is that? 1,327,850 kilometres squared for the area of country C. Okay. 14b. The population density of a country is the number of people per kilometres squared. Country C has a population of 82 million. Correct to the nearest million. Calculate the least possible value of the population density for country C. Okay, so to work out the population density, we do the total number of people divided by the area. So when we're working with division and bounds and we want the lowest possible value, we need to divide the lowest possible number of people by the highest possible area, because that's what's going to give us our lowest value for population density. So we are doing the lower bound of the people divided by the area. So the lower bound of people, well, it's got a population of 82 million, correct to the nearest million. Half of a million is 500,000. So the lower bound of people would be 500,000 less. So 81,500,000. So we're going to do 81,500,000 divided by the area that we worked out in part A. So 81,500,000. Have I got enough zeros there? 500,000. Yep. 1327850. It's always worthwhile checking that you're putting the right thing in your calculator, guys, because it could just give you a random answer. Okay, so we've got 61.377411462. Okay. So the least possible value of the population density for country C is 61.37, etc. I'm not rounding it because the question doesn't ask me to. 15a. Solve x squared subtract 36 is less than or equal to 0. Okay, so we solve inequalities the same way that we would solve equations. So I've got x squared subtract 36 is less than or equal to 0. So the first thing we're going to do is add 36 to both sides. So when I add 36, the left-hand side becomes x squared because minus 36 plus 36 is 0, so it eliminates it. When I add 36 to the right-hand side, 0 plus 36 is 36. Now, the important thing here is that I keep the symbol with the inequalities exactly the same as in the question. Okay, guys? Be aware of that when you're solving inequalities. We're not writing an equals sign here. The next thing I would do to solve would be to square root, because the inverse of squaring is to square root. So when I square root, I get x is less than or equal to 6. Okay, we've got to remember that x is less than or equal to plus or minus 6 because it's a quadratic and there are two solutions. We haven't finished there, guys. Okay, so we need to figure out what this would look like on this graph. So I'm just going to sketch the graph. So it's going to look something like this. So I'm going to have solutions at minus 6 and 6 and a y-intercept of minus 36. I'm interested in the solutions, the parts of this quadratic graph that are less than or equal to 0. So I am interested in anything below 0. So I'm interested in the bottom part of the curve there. So I need to figure out what the inequalities would be. So if I've got solutions at negative 6 and solution at positive 6, I want the values between them. So my actual solution should be written as negative 6 is less than or equal to x is less than or equal to 6, because it's that range of values here that I'm interested in. So I've got to make sure that I write a double inequality at that point. Okay, part B. On the axis below, sketch the part of the graph y equals x squared subtract 36 that represents the solution to the inequality x squared subtract 36 is less than or equal to 0. Mark any intercepts with the x-axis on your sketch. So it wants us to sketch this bit. Okay, so I'm going to get a pencil. So the part that I'm interested in would be, I'm not great at drawing curves, but it would look like that. So we're going to mark that as negative 6, 0. We're going to mark that as 6, 0. And we can actually mark that as 0, negative 36. So we've sketched that graph. It clearly said mark any intercepts with the x-axis, but I've put the y-intercept on there as well. Question 16. So we've got a diagram there. It's not drawn to scale, so we can't measure anything directly from it. So the diagram shows a sector ABD of a circle with centre D and a triangle BCD. Okay, so we've got this sector ABD with centre of the circle D, and we've got this triangle BCD here. Okay, ADC is a right angle, so ADC is a right angle, and that's marked on the diagram for us. It wants us to show that the area of ABCD is 150 metres squared, correct to 3 significant figures. So ABCD is the whole shape, so we need to find the area of the sector, the area of the triangle, add them together, and then show that it rounds to 150 metres squared to 3 significant figures. Okay, so I'm going to start with the area of the sector. And I like little labels. We'll have seen this by now because it makes it clear for me in case my brain goes to mush, but also makes it clear for the examiner if they're, because the examiners will be looking to give you marks, guys. They'll not be looking to take them away from you. So let's make it as easy as possible. So the area of a sector, so we're dealing with the sector only, guys. So the formula is theta over 360 multiplied by the formula for the area of a circle. So theta is the angle inside the sector, so this is clearly marked as 62 degrees, multiplied by pi, multiplied by the radius squared. Well, D is the centre of the circle, so the radius must be 15. So this is 15, but DB is also 15 because that's also a radius. It goes from the centre to the circumference. So we're going to multiply by 15 squared. I'm going to pop that into my calculator and see what it gives me. So 62 multiplied by 360, making sure, divided by 360, sorry, making sure, guys, that you arrow off your fraction, okay? We don't want it all in the fraction, so we're going to multiply by pi and then multiply by 15 squared. And we're going to write that answer down. So 121.7367153. And that's in metres squared. So that's the area of the sector. Now we're going to find the area of the triangle. Now this is not a triangle that we're used to. We don't have a perpendicular height. We normally would do base multiplied by the perpendicular height and then divide by 2. We don't have a perpendicular height on this triangle. So we're going to use the trigonometric formula for the area of a triangle. So it's going to be half times AB multiplied by sin C. So AB in our example are these two sides here. So we're going to do a half multiplied by 15 multiplied by 8. And then the angle, the sin C angle, is this angle here, the angle that's made by the A and B joining here at this point. Now this whole thing is a right angle that's 90 degrees. 90 subtract 62 is it 28? It is 28. I could have used my calculator. I don't know what I was doing. So this is 28. So it'd be sin 28. So we're going to pop that into our calculator. So 0.5 times 15 times 8 times sin 28. Close our brackets. So that gives us 28.1682937. So we want the total area because we want the area of A, B, C, D. So we're going to add those two together. So 121.736153 plus 28.1682937. So let's see what that gives us. So I've got one of them already still in my calculator. I'm just going to make it so you can... The light has changed. Okay, good. So I've got this one already in my calculator. So I'm just going to press add and then I'm going to enter the other one in. So 121.7367153. 121.7367153. And then I'm going to press equals. So that's 149.9050091. Now, it says show that the area of ABCD is 150 metres squared, correct to 3 significant figures. So let's round this to 3 significant figures and see what happens. So 1, 2, 3. So 9 is the third significant figure. The 9 after it in the 10th column is going to round that up. So it's going to be 150 metres squared to 3 significant figures. Question 17. The diagram shows the graphs of y equals x squared plus 1 over x and y equals 2x plus 1 for the values of x between -2 and 3. So we have the graph of y equals x squared plus 1 over x, which is this graph. We also have the graph of y equals 2x plus 1, which is this graph, okay, and the values of x between -2 and 3 are just telling us what the x-axis ranges from. So part A, show that where the line and curve intersect, x satisfies the equation x cubed subtract 2x squared subtract x plus 1. Okay, so where the lines intersect, so we're going to write those equations equal to each other and solve, because where the lines intersect are the solutions to the equations. So we have x squared plus 1 over x, so that's our first equation, is equal to 2x plus 1. I can write them equal to each other because they're both written as y equals. Okay, so yes, they're simultaneous equations, but I can write them written equal to each other rather than having to scale up and eliminate a variable. So we are going to solve this equation for x. So the first thing I'm going to do is I'm going to multiply by x because I want to get rid of this fraction. Okay, so everything gets multiplied by x. Now I'm going to start moving terms around, eliminating terms so that I can form an equation equal to 0. So I'm going to subtract 2x squared. So x cubed subtract 2x squared plus 1 equals x. I'm now going to subtract x. So x cubed subtract 2x squared subtract x plus 1 equals 0. We have shown that where they intersect satisfies this equation. X cubed subtract 2x squared subtract x plus 1. Okay, write down the solutions to the equation x cubed subtract 2x squared minus x plus 1 equals 0, giving your answer to one decimal place. So remember, those points of intersections are our solutions. So if we read off our x and y coordinates for each of those points, we're going to get our solutions. So we're going to have x equals and y equals and then an x equals and then y equals. So let's have a look. So this point here, we're working to one decimal place. So the x coordinate is -0.8. And the y coordinate is, my eyes don't want to work. Let's go with negative 0.2. Eduqas 0.5, because halfway is going to be -1. So I'm going to go with negative 0.5 for the y coordinate there. Okay, and then I'm going to read off the other one. So you've got to be really careful with this scale. You can see I paused then to make sure I was reading it correctly. So I'm going to read the x value as 0.6 and I'm going to read the y value as let's use my ruler to make this a little bit easier. So that's the point of intersection. So that's halfway point is going to be 3. So I'd say that's probably about 2.2. Remember, we're estimating solutions here as best as we can. So let's go with 2.2. So they're my sets of solutions. Question 18a. F of x equals x cubed. Find f to the -1 of x. So we are finding the inverse function. So that's the notation for an inverse function. So To find the inverse function, we're simply going to rearrange this equation. So instead of f of x equals x cubed, I'm going to write y equals x cubed to start off with, because that's a familiar form for me for rearranging equations. So I want to change it currently to be x equals. So to do this, I need to inverse the cube. Okay, to inverse the cube, I need to cube root. So the cube root of y is equal to x. But now I'm going to change these guys, okay? So I want x to be my f to the minus 1 of x notation, and I want my y to be x because that's the term that we're dealing with. So f to the negative 1 of x equals the cube root of x. Part B, g of x equals 5x subtract 1 to the power of 3. Expand and simplify g of x. Okay, so we are expanding triple bracket. So remember that power of 3 means that bracket multiplied by itself 3 times. So I'm going to start by expanding the two brackets at the start. So 5x multiplied by 5x is 25x squared. 5x multiplied by negative 1 is negative 5x. Negative 1 multiplied by 5x is negative 5x. And negative 1 multiplied by negative 1 is positive 1. I've still got that third bracket. But what I am going to do is I'm going to collect like terms inside that front bracket to start off with. Then I've got less terms to multiply by that third bracket. So 25x squared, negative 5x take away another 5x. So it's getting more negatives. So that would be negative 10x plus 1. And now we're going to expand these two brackets. So 25x squared multiplied by 5x is 125x cubed. Negative 10x multiplied by 5x is negative 50x. And 1 multiplied by 5x is plus 5x. Now I'm going to multiply all of these terms by negative 1. So 25x squared multiplied by negative 1 is negative 25x squared. Negative 10x multiplied by negative 1 is positive 10x. And positive 1 multiplied by negative 1 is negative 1. So now we're going to collect like terms again. So I only have one cubed x cubed term. All right. I have, that should be 50x squared. Very silly. Negative 10x multiplied by 5x is negative 50x squared. My brain. Okay, so I'm going to collect the x terms together. So negative 50x subtract 25x squared is negative 75x squared. Then we have 5x plus 10x. So we have 15x. And then we have the negative 1 on the end. Question 19a, so we've got a triangle drawn there and it says the diagram is not drawn to scale, so we cannot measure anything accurately from that diagram. The question asks us to calculate the length of BC. So it wants us to calculate this side of the triangle. Now it's not a right angle triangle, so I can't use SOHCAHTOA, I can't use right angle trigonometry, but I can use further trigonometry, so I can either use the cosine rule or the sine rule. You could use both on this question, but the cosine rule requires me to find out some additional information first and then to do a bit of rearranging. So I'm going to go with the sine rule, because the sine rule works when we've got opposite sides and angles like we have here, okay? And the sine rule tells us that A over sine A is equal to B over sine B. Okay, so let's just say, we'll write this as BC over sine 38. So BC over its opposite angle is equal to BA, which is 13, over sine of its opposite angle. So we're working out BC. BC is our x. So the reason why sine rule works lovely for this is I just need to multiply by sine 38. So BC is sine of 38. I don't know why I just wrote an equal sign there, guys. I'm so sorry. That's how my brain's working. I may need more coffee. So sine 38 multiplied by this whole thing. So 13 and then sine 67. So let's stick that in our calculator, being very careful. So sine 38, close your brackets before you press multiply, guys. And I'm going to enter this as a fraction, just to be sure. So that's sin 67, closing my bracket. So that is 8.694793.025. and it's centimetres because we're working in centimetres. Now the question doesn't ask me to round in any way, so I am not going to round the answer. I'm going to leave it exactly as it is. Okay, 19B. So we have another triangle, again not drawn to scale, so we cannot measure accurately from it. It wants us to calculate the length of EF. Now to calculate the length of EF, again, it is not a right angle triangle, so I can't use SOHCAHTOA. I am going to have to use the sine rule or the cosine rule. For this one, I am absolutely going to use the cosine rule. So the cosine rule works with sides, two sides, and the included angle. So if you've got two sides and the angle at the point where those two sides meet, we can use the cosine rule. So the cosine rule will be on a formula sheet, but it is a squared equals b squared plus c squared minus 2bc cos a. So a squared is what I'm looking for, so I'm going to say that's EF. So EF squared is equal to the other two sides squared. So 6 squared plus 11 squared, subtract 2 times 6 times 11 times by cos A, and my angle is 43. Okay, let's simplify this a little bit then. So 6 squared plus 11 squared equals 157. And then 2 times 6 times 11 is 132 cos 43. Why did I bother doing that? Why did I not just stick it all in my calculator? Because if I type all of that in my calculator compared to all of this, I'm going to make a mistake somewhere with a bracket or something, and I don't want that to happen. Now I'm going to type this in my calculator to find out EF squared. So 157 subtract 132 times by cos 43, close your bracket. So we have 60.461311139. This is EF squared. We don't want EF squared, we just want EF. So we need to square root that answer. And I'm showing very clearly that this is what I'm going to do. So if I do make a mistake on my calculator, hopefully the majority of the marks are still there for me. So I've left the answer in. I didn't clear my calculator. It's a good habit to get into, because now I'm going to press the square root button and the answer button. It'll take my last answer so I don't have to type this all out. Press equals. So EF is 7.7756879197. We are working in centimetres again. Both of the other lengths are in centimetres. It doesn't ask me to round, so I'm not going to. Question 20. Sean has 7 numbered cards as shown below. So 1, 2, 3, 4, 5, 6, 7. She shuffles them and turns them face down. She then turns them over to make a 7-digit number. How many different 7-digit numbers can Sean make? Okay, so this is a combinatrix question here, guys. So when she picks the first card, she has 7 to choose from. But once she's chosen that card, when she picks the second card, she only has 6 to choose from. And then when she picks the third card, she only has 5, and so on. So this is how we would find out the number, how many different 7-digit numbers she can make. They've put no other criteria on there at the minute, so this is as simple as it gets. So what we're actually doing here is 7 factorial. So we're going to do 7 times 6 times 5 times 4 times 3 times 2 times 1. So there are 5,040 possible combinations of 7-digit numbers that she can make. Okay, part B. How many of these 7-digit numbers are multiples of 5? Okay, this is where there's a criteria. So the only way this 7-digit number can be a multiple of 5 is if it ends in a 5 or a 0. Well, we don't have a 0 in these cards, but we do have a 5. So that 5 has to go at the end. Okay, so when we start picking the other cards, we've only got 6 to choose from for the first digit. So we'd have 6 times 5 times 4 times 3 times 2 times 1. And then the times 1 on the end for that 5 that has to be there. So 6 times 5 times 4 times 3 times 2 times 1 times 1. So we're doing 6 factorial times by 1, which is just going to be itself. So 6 times 5 times 4 times 3 times 2 times 1. We don't really need to put the times 1 on the end, but we're going to. So there are 720 of those numbers are multiples of 5. Okay, so part C, what proportion of these 7-digit numbers are not multiples of 5? So not multiples of 5 would be the total number, take away those that are multiples of 5. So 5,040 subtract 720. So 5,040 subtract my answer that was still there. So that's 4,320 are not, but we want this as a proportion. So that's 4,320 out of 5,040 all together. And if I stick that in my calculator, 4,320, 5,040 as a fraction, it will simplify that for me. So 6/7 of those 7-digit numbers are not multiples of 5. Question 21. An inverted cone is held in a stand, so we can see that here. The radius of the cone is 20 centimetres and the height of the cone is 50 centimetres, so 20 centimetres and 50 centimetres. Okay, Jake pours some water into this cone. When he stops, the radius of the surface of the water is 6 centimetres. The surface of the water is parallel to the base of the cone. This is important, that's helpful to us. Rhian then pours water into the cone until it's completely full. She pours the water at a rate of 1 litre per 10 seconds, so completely full. How many seconds does it take Rhian to fill the cone? Okay, so we would need to go to our formula list, guys. And on that formula list, it will tell you the volume of a cone. So it's 1/3 times pi times radius squared times height. Okay, so that's the volume of a cone. So we are working with the volume of a cone here. So, and it's similar shapes. So we're dealing with the volume of a large cone, the full cone, when it's completely full. But we're also dealing with the volume of this smaller cone here for when Jake pours his water in. Okay, so it's similar shapes. And the reason why we can use similar shapes here is because it tells us that the surface of the water is parallel to the base. So that surface of the water is parallel. So these cones are similar. So I'm going to start by finding the volume of the big cone, the full cone. Okay, because it doesn't matter which way around we do this. So the full cone would be 1/3 times pi times the radius squared, which is 20, times the height, which is 50. So the volume of the full cone is 1/3 multiplied by pi multiplied by 20 squared multiplied by 50. So that is, I'm going to leave it in terms of pi just to make my life easier. So that is 20,000 over 3 pi. Okay. Now, I want to find the volume of the small cone, but what I don't know about the small cone is its height. Okay, I know its radius, but I don't know its height. This is where the similar shapes thing comes in. So I'm going to find the linear scale factor. So I can find the linear scale factor by dividing the radiuses. So 20 divided by 6 is 10 over 3. Okay, so 10 over 3 is my linear scale factor. So if I do the height of the larger cone divided by 10 over 3, then that will tell me the height of the smaller cone. Okay, so height of small cone equals 50 divided by 10 over 3. 50 divided by 10 over 3, which is 15. So the height of the smaller cone is 15 centimetres. Now I can find the volume of the smaller cone. Okay, so the volume of the small cone equals 1/3 multiplied by pi multiplied by 6 squared multiplied by 15, which is 1/3 multiplied by pi multiplied by 6 squared multiplied by 15, which is 180 pi. Now the reason why I've found both volumes is because when Rhian pours water into the cone until it's full, Okay, she's only filling this bit of the cone, so I need to find out what the volume of that bit of the cone is so that I can then calculate how many seconds it takes her to fill it. So the way I'm going to find that, this is called a frustum, okay? And that's when you have a cone or a prism shape like this and you take off a similar version from the top. So you take a smaller version from the bigger version, and this white area is the frustum. So to find the volume of the frustum, we do the total volume, subtract the smaller volume. So we're going to do 20,000 over 3 times pi, subtract our answer, which is 19460 pi over 3. Okay, that's centimetres cubed. So that's how much water Rianne pours in to fill the cone, because this is what Jake did, and then Rianne does the rest. So she pours that much water in. Okay, so we're dealing with centimetres cubed. 1 centimetre cubed is 1 milliliter. Okay, so we need to change that into litres. There are 1,000 milliliters in a litre, so we're gonna divide by 1,000. So when I divide that by 1,000, I get 973 over 150 pi litres. Okay, this is important. It's not my final answer, and I've made a mess of my work in here, but bear with me. So she pours water in at a rate of 1 litre per 10 seconds. So that's how many litres of water she pours in. So we're going to multiply that by 10. So when we multiply that by 10, remember we're leaving things on our calculator to make our life easier. We get 973 over 15 pi. But I want to know how much that is in seconds. So that's 203.7846435 seconds. Question 22a. The first 5 terms of a sequence are shown below. So 5, 8, 11, 14 and 17. Complete the term-to-term rule for this sequence. So they've given us sequence notation here. So T1, term 1 is 5. Tn plus 1, so the next term is the previous term and then something happens to it. And this n is greater than or equal to 1. So the term numbers, so first term, second term, third term, fourth term, fifth term. Okay. So we need to find the term-to-term rule. So we're just going to see what's happening to this sequence. Now it's an increasing sequence because the numbers are getting bigger. To go from 5 to 8, we add 3. 8 to 11, we add 3. 11 to 14, we add 3. And 14 to 17, we add 3. So the term-to-term rule is to add 3 to the previous term. So I'm going to put plus 3 there. It's really important that you put the add. You can write the word add or put the symbol for add. Doesn't matter, but you can't just put 3. Because that would be this times 3, and that's not correct. What we're doing is adding 3 each time. Okay, part B. Show that x cubed subtract 2x subtract 5 equals 0 can be rearranged as x equals the square root of 2x add 5 over 8. So when we're dealing with iteration, because sequences are iterative, when we're dealing with iteration, the usual rules of rearrangement don't really apply in terms of you can do it in whatever order you want, okay? And it's because we're normally dealing with cubics or quadratics where we've got the variable appearing more than once. So what you need to do is spot what stayed the same or similar. So let's start off with, here we've got x cubed minus 2x minus 5 equals 0. Here we've got a 2x plus 5 here. So it's not a minus 2x minus 5, but it's a 2x plus 5. So that means that these terms have been moved over to the other side because the inverse of subtract 2x subtract 5 is add 2x add 5. So let's start by doing that. So x cubed equals 2x plus 5. Okay, now look at what else has happened. Okay, we've then divided by x and then we've square rooted. Well, we would square root if this was an x squared, so divided by x makes sense. So let's divide by x. So x cubed divided by x is x squared. but then we have to divide this side by x. Okay, we're looking good here, guys, because what's inside the square root matches. Now we need to show that we would square root x squared to get x. So we would write it as 2x plus 5 over x. Okay, B part 2. Use the iterative formula. So the next solution is equal to this iterative formula. So it's 2 times the previous solution, add 5, all divided by the previous solution, and we're starting with a value of x equals 1. We're finding a solution to that equation correct to 1 decimal place. So this equation is this equation, which is the same formula. It's just been written with iterative notation. So our first solution is x1 equals 2. So to get our second solution, we substitute that value in wherever we can see xn. Okay. So the next solution is the square root of 2 times our previous value plus 5 divided by our previous value. And what I'm going to do, I'm going to put that in a bracket because it helps me remember that that's where I need to substitute in the previous value. Okay, you might do it differently. And then I'm going to press equals, and then I'm going to write that as a decimal. So 2.121320344. I'm aiming for 1 decimal place, so I'm going to keep going a little bit longer because I want to see it all converging or diverging to the same 1 decimal place. Okay, so let's get the third value, but this time I've not deleted what's in my calculator. So what I'm going to go back and do is to use, not deleted anything that's on my calculator. So what I'm going to do is I'm going to type that formula in again. So it's 2 times my answer, my previous solution that's still in my calculator, plus 5 over my answer. So let's press equal. So that gets us to 2.087348223. Okay, I'm going to go again, but because I'm using answer here, I can just press equals. And this is the point where our life gets pretty easy with iteration questions. So let's get x to the power of 5, so 2.094017159. Now we're aiming for 1 decimal place. So what we're looking for is when this starts to look the same, okay, starts to repeat, but obviously these values on this side will make a difference potentially to round it. So I'm going to get my next value, which is 2.094696882. So you can see here 2.09, 2.09, 2.09. So I can quite confidently say that a solution to this equation would be x equals 2.1 to 1 decimal place, because even here 2.08 would be 2.1, 2.09, 2.1, 2.09, 2.1. I had to wait for this to be repeating really before I decided that it was 2.1. But I'm going to go with that, x equals 2.1. Question 23. In this question, x and y are horizontal and vertical distances in metres. An engineer designs a tunnel. He models the uniform cross-section of this tunnel using the graph shown in the diagram. So this is the cross-section of the tunnel. And actually it does look like a tunnel. If you've ever driven through a tunnel in any kind of vehicle, that's what a tunnel entrance would look like. So the tunnel is 50 metres long, and it will cost £250 per metres cubed to excavate it. So we're using the graph with 4 vertical strips of equal width to calculate an estimate of the total cost of excavating this tunnel. So this, guys, is working with the trapezium rule. Okay, so we're going to estimate the area of this cross-section of the tunnel to start off with. Now I'm going to use a pen because I want you to be able to nice and clearly see my lines, but I suggest that you potentially use a pencil because you don't want to have to rub out a load of lines or have a load of lines in pen and not make it clear to the examiner. So I want 4 strips of equal width. So I'm going to have 1, 2, 3, 4. So let's start with that. So we're going to draw lines up from each of those points. Okay, so we've got 1, 2, 3, 4 strips of equal width, but we are estimating, so we can't actually use the curve. We're going to form trapeziums here, guys. So the estimating part is the fact that that little gap between this edge of the trapezium and the curve is not going to be involved. But that's okay because it's an estimation. Okay, so we have 4 strips that are trapeziums. So we have A, B, C and D. So we're going to find the area of each of those. So remember the area of a trapezium. So let's find the area of A. So we do the parallel side. So this is 4 and this is 7. So we're going to do 4 plus 7 equals 11. And then we times it by the height, the distance between them, which is 3. 11 times 3 equals 33. And then we half it. So 33 divided by 2 is 16.5. Okay, so that's the area of that section. We're going to do the same for B. So the area of B. So parallel sides, so this is 7 plus 8. And then we're going to times it by the distance between them, which is 3. And then we're going to half it, which is 22.5. Let's do the area of C now. So C and B should be the same. But let's check. So it's 8 plus 7 times by 3. Yeah, so we can say that the area of C is 22.5. The reason why they should be the same is because this is a quadratic. This is a parabola. And they have a line of symmetry. So, but it's worth checking. And then I'm hoping that A and D are the same. But we'll find the area of A anyway, area of D anyway, just to be safe. So that would be 7 plus 4, 7 plus 4, times by 3, and then half it. So that is 16.5. So meters squared, meters squared, meters squared. So we're going to get the total area. So the total area, or the total estimated area of that cross section is all of those added together. So total area equals 16.5 plus 22.5 plus 22.5 plus 16.5. Okay. Which is 78. So it's a total area of 78 meters squared. We're dealing with volume, so we need to find the volume of the tunnel so we can figure out the cost to excavate. So the tunnel's 50 meters long. So this is the cross section, the uniform cross section of the tunnel. So if it was a 3D shape, we would multiply by its length. So 78 times by 50 times by 50 is 3,900 meters cubed. Wonderful. That's a total volume. It costs £250 per meters cubed to excavate. So we're going to times that by 250 to find the total cost. And again, this is where not deleting things out of our calculator helps us a little bit with time and accuracy. So it should cost £975,000 to excavate that tunnel. So £975,000. And that's the end of the paper.